Welcome back to Excel for Economics. We're going to be looking at some more random numbers. In this case, we're going to be looking at the probability of observing a value for a given distribution. If we're looking at the standard normal, what we use is we say norm dist. And this says if I observe -5, and I have the standard normal distribution, and then what I want is the probability of observing that value. What's the instantaneous infinitesimal probability? So we put false. This is from the PDF, the probability density function. And that'll give us the probability of observing that. And then we can drag this down and find out where the probability is. And we can see that the probability is the highest at 0, where it's at nearly 40%. And then it drops back down again. We can see this in a diagram, this being the normal distribution. If we had smaller increments, then we'd have a much smoother chart. If we look at the chi-square, we can do the same thing, where we take chi-square distribution. We want our data, which is A9. Degrees of freedom, we're going to choose 4, and we want false again for the PDF. And here we get a bunch of nums. Why? Because the chi-square is just that squared, so it has to be positive. So there's the probability below 0 doesn't even make sense to it. So 0 above, it makes sense, and you can see that it's starting its long tail out to the right. T-distribution is symmetric. Again, A9, degrees of freedom, we're going to choose 4 and false, so that we get the PDF probabilities. And here we can see that the gray one will have a thicker tails, such that more of the density is out to the right, so it has a higher kurtosis. The F distribution, A9 again, degrees of freedom are 4, 7, and we want this to be the PDF. And here we can see that it's very sharp, very close, but it also has a longer tail, and it also doesn't make sense to have it as a negative value as an input. Next is the cumulative density. So this would be the summation of everything up until everything at a value of interest, let's say 0 and negative, and you'll see that this would need to sum up to the probabilities. So we can take this and we go norm dist A9, 0, standard deviation, or the variance standard deviation is 1, and then this time we put in true. And here we can see what happens to our CDF as this thing goes forward, goes up. It extends and reaches 1 or asymptotic to 1 once it gets high enough, well above 2. Chi-square, chi-square dist, A9, 4, through. Doesn't make sense below 0, but once it hits 0, then the probability starts to rise pretty rapidly. T-distribution, A9, 4, through. And again, a little bit thicker tails, so it will have a higher probability before and lower after 0. Last one is the F distribution. 9, 4.7 through. Doesn't make sense for a negative value, but afterwards it rises quite rapidly, such that a very large proportion of the probability is below 2. As we can see here, it gets up to 80% by 2, whereas the chi-square by 2 is barely above, just below 0.3. Okay, so this is how we are able to obtain the probability densities and the cumulative density of different types of functions available in Excel. And we'll see you in the next video.